Okay, let's unpack this. We often think of our sun as, this constant, unwavering source of light and warmth, the very basis of life here.
Right, steady Eddie up in the sky.
Exactly.
Yeah.
But beneath that seemingly calm surface, there's just immense unseen power. And the thing is, what happens on the sun millions of miles away, it can have really surprising, significant impacts right here.
Absolutely. It's not as disconnected as we might think.
So today, we're doing a deep dive into something pretty groundbreaking. It's a brand new AI model. NASA and IBM developed it. And it's designed not just to predict the sun's behavior, which is cool enough, but crucially, to help, well, safeguard our world, our tech world.
That's it exactly. Our mission here really is to explore how this cutting-edge AI trained on just vast amounts of solar data isn't just, pushing solar science forward.
Okay.
It's actively working to protect the technology we all rely on. Everything from GPS in your phone to the power grid.
Yeah.
We're diving into a really fascinating recent article from NASA Science on this.
Okay, so beyond the nice sunny days, why should you, listening right now, care about solar activity? It's not just a giant light bulb, right? It's dynamic, sometimes pretty volatile.
Very volatile at times.
So what are the actual stakes for us when the sun, acts up?
Well, the stakes are surprisingly high. And they're getting higher as we rely more on technology. These powerful solar events like solar flares or coronal mass ejections, think giant bursts of energy and plasma.
Right.
They have very real-world consequences. For instance, they energize Earth's ionosphere, that upper layer of the atmosphere.
Okay.
And that can lead to pretty substantial GPS errors or even complete signal loss for satellite communications.
So if my phone's map goes haywire or the car navigation gets weird, that could literally be the sun messing with us.
It absolutely could be.
Yeah.
And it goes deeper. Our power grids, they're also at significant risk.
How so?
Those coronal mass ejections, CMUs, they can induce these things called geomagnetically induced currents, GICs, in power lines on the ground. And those currents can overload transformers, potentially trigger, widespread power outages. We've seen smaller events cause trouble before. It's a real wake-up call.
That's a pretty chilling thought. Widespread outages. What about other essential stuff, like flying?
Commercial aviation is another big one. Solar flares can disrupt vital radio communications, navigation systems.
Right. Pilots need that.
Exactly. And for high-altitude flights, there's actually an increased risk of radiation exposure for passengers and crew during strong events.
Wow.
And then think about human spaceflight. This is critical. Astronauts heading to the moon or Mars. They'll need precise predictions to know when to shelter from intense radiation bursts, solar particle events.
It could be life or death, really.
Truly, if they're caught out in the open, unprepared. And then there's the satellites themselves, especially in low Earth orbit.
The ones for, like, global internet, Starlink and others.
Exactly those. There are thousands up there now. When solar activity ramps up, it heats Earth's upper atmosphere, makes it expand, basically. That increases atmospheric drag on satellites. It slows them down, pulls them lower, and can even cause them to re-enter the atmosphere prematurely.
So they just fall out of the sky sooner than expected.
Effectively, yes. And satellite operators, they often struggle to forecast these drag effects with the kind of precision they really need. It's a constant challenge. There's a quote from Joseph Westlake. He's the Heliophysics Division Director at NASA HQ. He really puts it well.
Okay.
He says, "Our society is built on technologies that are highly susceptible to space weather. Applying AI to data from our heliophysics missions is a vital step in increasing our space weather defense." Basically, protecting everything from astronauts to GPS to power grids.
That really drives it home.
Yeah.
How much our modern lives are, well, exposed to the sun's moods, you could say.
Exactly.
So, okay, we've got these real threats. Our interconnected world is vulnerable. How do we get ahead of it? And that's where it gets really interesting, this new thing, Surya.
Surya, exactly. It's a new heliophysics AI foundational model developed by NASA, partnering with IBM and several other collaborators.
An AI model. What makes it so powerful? You mentioned the training.
Yes, the training is key. Surya was trained on 9 years of observations from NASA's Solar Dynamics Observatory, SDO.
9 years. That sounds like a lot, but is there something special about that data? I imagine we have tons of solar observations.
That's a really good question. It's not just the amount, it's the quality and consistency. SDO launched back in 2010.
Okay.
And it's given us this unbroken, high-resolution record of the sun for, well, nearly 15 years now. It takes pictures every 12 seconds
Uh,
in multiple wavelengths of light, plus it gets precise magnetic field measurements. And because it's stable, well-calibrated, and covers a whole solar cycle, it's uniquely suited for training an AI like this.
so it's like giving the AI a really clear, long movie of the sun?
Exactly. A complete high-def movie over a decade. It lets the AI see subtle patterns that you'd miss with shorter, patchier data.
Makes sense.
And Surya's architecture is important, too. It's a foundation model.
What does it mean exactly?
It means it learns directly from the raw solar data itself. So unlike older AI systems where humans had to spend ages labeling features, this is a flare, this is a sunspot, Surya learns the underlying physics.
Okay, so it's more self-sufficient.
In a way, yes. It makes it adaptable. You can quickly point it at new tasks or applications without massive retraining or labeling efforts. Kevin Murphy, NASA's chief science data officer, he emphasized this.
Yeah.
He said they're embedding NASA's deep scientific expertise into cutting-edge AI models, and that this foundation model approach makes analyzing the sun's complexities faster and more precise, helping us understand its impact on, critical systems here on Earth.
That sounds incredibly powerful, integrating deep science knowledge into the AI. So practically speaking, what can Surya actually do right now? What are the results?
Well, it analyzes all that SDO data to help scientists understand solar eruptions better and, crucially, predict space weather.
The forecasting part.
Right. It can give early warnings to satellite operators, maybe give them time to put satellites in a safe mode. It also helps predict how the sun's ultraviolet output affects the upper atmosphere, which links back to that satellite drag problem we talked about.
Gotcha. So it's helping with multiple issues.
Definitely. But one of the most groundbreaking things is its success in solar flare forecasting. That's been a notoriously tricky problem in heliophysics for, decades.
And Surya's cracking it.
It's making serious headway. It can actually generate visual predictions of solar flares 2 hours into the future.
Visual predictions, not just a probability number.
Exactly, like a movie forecast of the flare developing. And its initial results are really impressive. They're surpassing existing benchmarks by about 16%.
16%. That sounds like a significant jump.
It is, especially for visual forecasting 2 hours out. That's a big leap. And there's evidence it's really learning the physics. Preliminary results suggest it can predict the structure and evolution of a flare just by looking at its very beginning stages.
Wow.
They've shown this by comparing what Surya predicted versus the ground truth data, what actually happened on the sun. The match is pretty compelling.
So it's not just flares.
No, it has other applications too. Tracking active regions on the sun where flares often originate, forecasting general flare activity levels, predicting solar wind speed, which also impacts Earth. And it can integrate data from other missions too, like SOEO or Parker Solar Probe. It's quite versatile.
That's incredible. So this isn't just about predicting solar storms, is it? What does this mean, kind of bigger picture, for science overall?
It definitely has broader implications. Surya is part of a wider push by NASA to develop open access AI-powered science tools.
Open access.
Yeah. Both the model itself and the huge training data sets are being made freely available online for researchers, educators, students, anyone really.
That's huge.
It really is. The idea is to lower the barriers, let more people work with this data and technology, and hopefully spark all sorts of new discoveries we haven't even thought of yet.
So the way Surya was built, this foundation model approach, could that be used for other kinds of science, not just the sun?
Absolutely. That's a key point. While Surya is tailored for the sun, its core architecture, the methodology, it's adaptable.
Okay.
You could potentially apply similar techniques across different scientific domains. Think planetary science, studying other planets, or Earth observation, climate modeling. It sort of lays the groundwork, the infrastructure for similar AI efforts in lots of fields.
A template for future AI in science.
Kind of, yeah. And this project also shows the power of collaboration. Surya's training got support from the National Artificial Intelligence Research Resource Pilot, the NRR pilot.
NRR pilot.
Yeah, it's an NSF-led thing. It brings together government and industry resources like computing power from NVIDIA to give researchers access to advanced computing, big data sets, AI tools.
So pooling resources.
Exactly. Katie Antepis, who directs NSF's Office of Advanced Cyber Infrastructure, she said this project shows how NAIR is uniting these resources to speed up breakthroughs and lay the groundwork for a national AI network for future discoveries.
It sounds like a massive undertaking, not just NASA and IBM, But getting computing resources, other partners.
Oh, definitely. The collaboration was extensive. You had NASA's impact team at Marshall Space Flight Center, IBM, of course, and then a whole science team from universities and NASA centers, Southwest Research Institute, Uni of Alabama Huntsville, Colorado Boulder, Georgia State, Princeton, Goddard, JPL, even the SETI Institute.
Wow, that's quite a list.
It really shows the kind of all-hands-on-deck effort needed for these big, complex science challenges today.
Yeah, absolutely. This deep dive really highlights the just incredible potential of AI like Surya. It's not just about understanding the universe better, which is amazing in itself.
Right.
It's directly impacting our lives by helping protect the technologies our modern world is built on. It seems clear that this kind of advanced data analysis, boosted by AI, is becoming really critical for space safety.
Couldn't agree more. And it leaves us with a really interesting thought to chew on, doesn't it?
Hmm.
Well, think about how this powerful AI, designed first for the sun, could be turned towards other incredibly complex scientific data sets.
Like what?
Imagine applying similar techniques to climate modeling, trying to get better long-range forecasts, or maybe analyzing data from distant exoplanets, trying to understand their atmospheres or environments.
Ah, okay. Using the same approach for totally different puzzles.
Exactly. What unexpected discoveries or, totally new applications might pop up down the road, things we can't even really imagine today. It's quite exciting to think about.